Greetings, math fans. All right, so you have 4 problems to do for homework. They're not too bad. Let's start with number 47. So I'm going to read it off here real quickly. It's a storage bin. It says find the dimensions of the largest open top, that's important, open top, storage bin with a square base, which also is important, and vertical sides that can be made from 108 square feet of sheet metal. So here's the deal. First of all, just to write out here, our dimensions of this box are x times x, because it's a square base, times the height. Okay? And what we're doing is our steel used, which is really our surface area, is x squared, right? It's the bottom, plus, think about it, each side, if that's the bottom, it's x, and then its height is here. Isn't x times h gives you the area of that? But there are 4 of them, right? Because it's 4 sides. So 4xh. So that is your surface area, and they tell you that that is equal to 108. So this is one nice little friendly formula here. And then they tell you the volume is, they're asking you to find the maximum volume here, right? So we have V of x is equal to, well, the volume of that is x squared times h, right? Let's take the area of the base times the height. And we're trying to maximize that. Well, the deal is that I can't do, if I take the derivative, I'll have 2 variables. I've got x and h, and I can't deal with x and h. I can only deal with one of them. So the nice thing about it is I'm going to solve for one of these variables. I can solve in this one, in the steel used, I solve for one of them. Now, guys, which one makes sense to solve for? It makes sense to solve for h. If you solve for x, you're going to factor something out. I mean, that's just brutal. You can even see that. So if I solve for h here, I get 4xh equals 108 minus x squared, and I divide by 4x. So you get h is equal to, just here it is, it's 108 minus x squared over 4x. Okay? And then I substitute that back in here. It's pretty easy. So I get V of x is equal to, and again, I can just kind of multiply that out a little bit right on top. Well, here, let me just leave it this way. X squared times 108 minus x squared. Remember, you always try to simplify this as much as possible. If you have to take the derivative of it, and it's complicated, you're more likely to make a mistake. Well, look at this. This is nice. This squared cancels out with that x right there. So I really have V of x is equal to 108 x minus x cubed over 4. In fact, let's even split up more. Let's write as 108 divided by 4 actually is 27. Oh man, that's so nice. Minus 1/4 x cubed. Man, that is so much nicer than trying to deal with a brutal, just a brutal problem. So now I can do v prime of x is equal to 27 minus 3/4 x squared. Okay, so let's solve it. 3/4 x squared equals 27. Multiply both sides by 4/3. And I get x squared equals, that's a 9 and a 1, so 36. So x equals plus or minus 6, and as you well know, you can't have a dimension that's negative, so my dimension is x equals 6. Okay, so we need to do interval testing. It's important. So we do 6, and we're going to do 5 and 7, plug it into the derivative equation, and you wind up getting positive and negative if you test it out correctly. Okay, which means it is a maximum, right? And by the way, that is our, that's one dimension, okay, and then we got to find out our h, and of course we just plug that back into where we solve for h right here. And if we do that, we get h is equal to 108 minus 6 squared over 4 times 6, and h comes out to be 3. Okay, and I think it's in feet, so 3 feet, and x is equal to 6 feet. Okay, and those are the dimensions that maximize the volume. Now, do you have test endpoints here? No, you don't. Okay, because you can't have a zero dimension. So that's kind of nice. All right, let's do number 58. I'm going to skip 56 for now because I want to do that one at the end. It's a calculator problem. So 58 is the radius of a circle is changing at a rate of -2/pi meters per second. At what rate is the circle's area changing when r equals 10 meters? Okay, that's actually pretty nice. Let's write a couple things down here. We have, first of all, dr dt. The rate is changing at -2/pi meters per second. Kind of a nice thing. Okay, and then they're telling you r is equal to 10. Again, you're never going to plug in anything until the very end. All right, so they're asking you at what rate is the circle's area changing when r is 10? So area equals pi r squared. It's all nice. Everything, we just have two variables here, so we're going to take the derivative, and we're going to do dA dt is equal to 2 pi r dr dt. Sweet. Okay, and we have our r, and we have dr dt. So plug it in. So dA dt 2 pi times 10 times -2/pi. So dA dt is equal to -40 meters per second. And make sure you have the right units. You know it's change in area. So obviously that's going to be meters squared, right? Very good. -40 meters squared per second. Okay, it's not bad. Okay, let's look at number 60. We can just put that one right next to it here. Changing cube. The volume of a cube is increasing at the rate of 1,200 cubic centimeters per minute. Okay, so that's going to be dV dt equals 1,200 cubic centimeters per minute. Okay, and then it says, or at the instant the edges are 20 centimeters long. So one side, we'll call this S, equals 20 centimeters. It says at what rate are the edges changing at that instant? So the thing you just need to do is you need to come up with a nice little friendly equation for volume of a cube. Well, that's pretty easy. Its volume is equal to side cubed. And what are we looking for? It says at what rate are the edges changing? So we're looking for ds dt. Okay, so again, it was pretty mellow. We're going to do dV dt is equal to 3s squared ds dt. All right, and so we have 1,200 is dV dt times 3, and I give you s is 20 squared ds dt. So it's 1,200 equals 20 squared is 400 times 3 is 1,200. That's friendly. Divide by 1,200 and we get ds dt is equal to 1. And it's change inside over time. So it's 1 centimeter per minute. Okay? Not bad. All right, last problem is a calculator problem. Definitely need to use a calculator for the one. It says the position of two particles on the s-axis are s1 equals cosine of t and s2 which equals cosine of t plus pi over 4. I want to do actually b first. B is actually a lot easier. When do the two particles collide? Well, isn't that when s1 is equal to s2? You guys agree with that? So let's put this in our graphing calculator here. I'm going to clear this out of here and pull up our graphing calculator. So hit y equals, and I know they use s, but we can use x. Okay, it doesn't really matter. Anyway, we put the first thing you have to do also, make sure you check. Go to mode. See, I have it in radians there, or I have it in degrees. That will give us a very bad answer. So I'm going to hit enter and put it into radians. And now I'm going to hit y equals. And I'm going to put cosine of x. It's a good habit to close parentheses. And then I'm going to put cosine of x plus pi over 4. Close parenthesis. Okay, and then let's graph it. So let's do zoom. We'll do zoom trig. Zoom 7. Yours is probably faster. Mine's a little slower. Okay, and I'm asking you guys, when do the particles collide? Well, they collide actually a lot. Okay, but if I want to do an intersection here, let's do one intersection here. In fact, let's do one. So we're going to do second calculate, and we can do intersect, number 5. Okay, and the first curve, enter. Second curve automatically does it, right? And then hit guess. And it found 1 point there. Okay, and it says negative 3.927. Right? Negative, so let's write that down. Negative 0.3927. Okay, so think logically, math fans. This is one intersection. The calculator is not giving you, it's giving you this guy right here, right? What is this one? How far is that away in terms of radians? Okay, do you guys agree? I go from here to here. Well, actually, one complete period is 2 pi, isn't it? So what does it look like it's doing? If this is one period here, isn't it doing every pi? So that's actually the answer to this problem. It's negative 0.3927 plus and plus n pi, where n is an integer. It's not that bad. All right, the next one's just kind of a little tricky. This is part A. It says, what is the farthest the particles will ever get apart? So that's interesting. If I make a quick sketch here, if I said how far are the particles, so if I have something like this, and let's say I have something like this, and if I ask you what's the farthest they're getting apart, what am I looking at? I'm looking at these distances here, right? So I'm looking at the distance. This is really where it's farthest apart right here. Well, how do I get that? Well, here's an interesting thought. Can I look at the differences between these? If I say curve A minus curve B, but if I take the absolute value of that, right? Because it could be in this point right here, and I don't want it to be negative. So can I look at that, and can I look at the maximum value of that? So I can create another function like y3 is equal to the absolute value of that, and then find the maximum space, right? That's because I'm graphing spacing. So I'm going to look for the maximum value of that. It's kind of interesting. Okay, so let's bring up our calculator and type that in. So we already have these in here, but I'm going to put in the next one. So I'm just going to say the absolute value. So we go under math, number, cursor over, and then you do absolute value. Okay, and then I'm going to put in y1. So you could type the equations in again, but I don't like to do that. So vars, y vars, function, y1 minus vars, y vars, function, y2. Okay, and if I would graph it, I'm going to get all 3 functions. I really don't want all 3 functions there. So what I want to do is I want to cursor up here. I want to hit enter for these two and actually turn off the equal sign. And then if I hit zoom, I'm going to hit zoom 6 now because I'm really not graphing the trig function anymore. I'm graphing the difference. So if I hit zoom 6, this is what I get. So I'm looking for the maximum, and let's zoom in a little bit more because that's actually not very good. So if I do zoom in and enter, okay, so I'm looking for those maximum values, right? And let's do that. So second calculate maximum 4, and left bound, go there, and right bound. Okay, that's good enough. hit enter, and enter for guess. So the answer, remember, we're looking for the y value, not the x value. We're looking for the y, and it's 0.7654. Okay, so that's our answer to that one. 0.7654. That's for A. Okay, and this guy was here. That was for part B. So this is kind of a good exercise using your graphing calculator. So anyway, that's it for day 8, math fans. Have an outstanding day. Adios. Goodbye.